Hey folks, welcome back to part 33 of manual testing series. In this video, let's talk about what is integration testing and what are the different types of integration testing is available. Okay, before we begin, if you have not subscribed to the channel, please do subscribe to the channel. Let's get started. Integration testing is the second level of software testing process, comes after unit testing. In this testing, units or individual components of the software are tested in a group. In the previous video, one of our video also we have discussed about the integration testing. But here, if we want to talk about integration testing, when there is one module which is ready, which has been unit tested, now another module is also ready. Now it's time to combine both of these module and to test it to verify the data flow between these two units. Okay. The focus of integration testing level is to expose defects at the time of interaction between integrated components or the units. So basically, with the help of it, we can verify how the interaction is happening between two different modules. Okay. So that is the main focus. That's where we will perform the integration testing. And here the goal of integration testing is to check the correctness of communication among all the modules. So suppose if you have built a login module and now you have to integrate it with another page, right? Another module, which is basically. So once the user logs in, he should be navigated or redirected to some other page. So at that time, there will be a interaction between two different pages, right? So here we will verify the correctness of communication among all the different modules. Once all the components or modules are working independently, then we need to check the data flow between the dependent modules is known as integration testing. So once all the components are working individually, basically, particular unit is working perfectly fine. So now it's time to verify based on how the data flow is happening. To give you an example, let's say in an e-commerce application, what happens is once you add a product to the cart, you can go and verify in the cart, right? So here it is a different page. And once it is added, whether it is getting added or not, that you can verify in a different page. So here the integration should be there. Or even in case of payment also, once the user clicks on checkout, whether the integration is properly there or not needs to be verified properly in the integration testing. So initially, first one module will be ready and then it will be tested with another module. Okay. So one specific unit will be integrated and then tested, and the related modules also will be tested along with that. So this is how the integration testing works. Certain different types of integration testing. Let's talk about it. The first approach is bottom-up integration testing approach. Here, testing starts from the lowest module in the architecture. The testing control flows flow moves upward from the bottom. So basically, uh, suppose say one module is ready, but the above module, okay, the related module which is above it is not ready. So in that case, how we can test? Yes, we will talk about it. This method will be executed when the top modules are under the development. This method will use drivers to restore the working modules that are missing. This way of approach has high success ratio and is an efficient way to test and develop a product faster than the other traditional models or methods of the testing. Basically, this is the word that you have to remember. Case if the module, for example, we talked about the e-commerce module. Suppose say um, add cart page is ready, okay, add to cart, but the previous page where we can add the product, right? So if that page is not ready. So then how can I test the other module, like the add to cart page? So that is where the driver comes into picture. Is the it will start from the bottom. Okay, the bottom module will be executed first here. The integration between the bottom up, as the name suggests, the testing starts from the lowest module. Okay, suppose say add to the cart comes into picture last while the user can check out, right? Now the add to cart module is ready, but the other module, whichever I'm talking about, is the screen where we can add the item. So if that is not ready, at that time we will create something called driver in case if we want to test the bottom up approach. So this is how it looks like. Suppose say M1, M2, M3, M4, there are different modules. Okay. While we test this bottom up integration approach, suppose say M6 module is ready, M7 and then M5. These modules are ready. First, we can verify it with the available modules. In case if it is not available, we can create the drivers and then we can test it. Okay. First, you can finish off your testing with, M4, M7, whichever module is ready. In case if it is not ready, you can go ahead and then create drivers. So this is how the bottom up integration testing approach works. Next is top down integration testing. In this approach, testing is performed from the topmost module in the architecture. So the testing control moves from the bottom to the top. So basically from top to the bottom it is supposed to be. Why? Because suppose say login is the very first module. Okay, once you log in, then itself you will be able to add the item. Suppose let's say once we log in only, we are allowed to add the product to the cart. So at that time here, the top module, which is login, is ready, and then the next module where the items will be displayed. Okay, that screen is ready. So in that case, what happens is basically from the topmost module, we will start the testing. This method will use struct as duplicate program to restore the working modules that are missing. Suppose in case the other module is not ready, the dependent module, let's say now we will say that login module is ready and then the item card, the place where we can see the card is also ready. But add to card screen is not ready. Now what we can do is if these two modules are ready, we can create stubs. Okay, we can create stubs and then it is a like a duplicate program. It is a dummy code basically. We can create that and then we can continue our testing. So two things you have to remember is in case of bottom up approach, you will create drivers. In case of top down approach, we will create the stubs, which are basically the dummy programs, which is like just to test, to complete the testing, it is a dummy piece of code that will be there. It is not, it might not be an actual working code also. This method is comparatively easier than bottom-up approach as it uses stubs, which are generally easier to write than drivers. With this approach, you can find interface errors with ease because of its incremental nature. So one after the other itself, we will be executing. So that is where it is good to go for this top-down approach because one top module will be ready and then the bottom next module will be ready and then the next module. So like that, it will happen in an incremental way. Okay. So that is why it is better to use this top-down approach. Suppose all these are the different modules and then first we can go ahead and then test this M1 and then you can test the integration with M1, M2, M3 and M4 and then with M5. So all different one after the other. Suppose say now the four modules are ready, so you can go ahead and test only the four modules. Once the fifth module is ready, you can test the fifth module and then once other modules are ready, in the same way you can add and then you can add a different module and then you can proceed with testing. So this is better suitable compared to the bottom up. The disadvantage in bottom up is It is difficult because even from the testing perspective as well, it is difficult. And also in case of any errors are there from bottom level to top level, it is difficult to identify also. Okay. Sandwich integration testing. It is a combination of bottom up and then top down approach. Bottom modules are tested with the top modules at the same time. The top modules are tested with the lower modules. Okay. Suppose say there are few modules from the top is ready and then few modules from the bottom is ready. Okay. So in case if you're getting confused with what the modules could be, each of the screen consider it as a different module. As I mentioned, login is a module, and then after logging in the home page, whichever comes is another module, and then the screen where you can see all the details is another module, and then I know after on click of it you will see all the details of the product, so that is also one different module. And then add to cart, if once you add it to the cart, that will take you to another different page, so that is also a different module. And then checkout, even that is also a different module. So imagine all these are different modules, and suppose very few modules from the top like login and then the home screen, all these are ready. Okay. And from the bottom, add to cart and then the payment integration is ready. So in this sandwich approach, in the middle, suppose middle modules are not ready, at that time we can go for this sandwich approach. Okay. The goal here is to reach the mid module by testing both top and then bottom modules simultaneously. This approach uses both stubs and drivers. Okay. So sandwich is the combination of top down and then bottom up approach. Okay. Like this. It is a hybrid approach, you can say. And then suppose say module one module, it is like a dependent. Okay. Certain modules from the bottom are ready, certain modules from the top are ready, but the mid module is not ready. At that time, you can go ahead and create stubs and drivers because it is a combination of top down and then bottom up approach. So that is how the sandwich approach. Finally, we have one another approach, which is Big Bang integration testing. Big Bang approach. This type of testing is usually performed only after all modules are developed. Once developed, all the modules will be coupled to form a single software system, and then the testing will be performed. Okay, so you have to wait until all the modules are ready in this Big Bang approach. This sort of testing generally suits smaller systems, though every module will be developed before even testing on the integration, starting the integration testing. The biggest disadvantage here is some of your resources will be unproductive as they have to wait for all the modules to be developed before starting the testing process thus making it costly and time consuming. So Big Bang approach is where you have to wait until all the modules are ready. After all the modules are ready, then you will start working on integration testing, which is time consuming because in case if you find any errors in the module 3, you could have found it if you have implemented a different method like top down approach. Okay. Until you waited for all long days and then once everything is developed, now you're going to test and you found the defect in module 3, which in turn in case if it flows to the next module, it is costlier to fix it, right? So as soon as each of the module is ready, it is better to go ahead and test it. So that is where these are the different approaches that we have in integration testing. Hopefully, have got what is integration testing and what are the different approaches that we can have as part of this integration testing. If you have liked this video, please do like it, share it, and don't forget to subscribe to the channel. Thank you for watching. Bye bye.